Let's go to Lico 2044. Count number of maximal bitwise-OR subset. For this question, it gives us integer numbers. And we know there are some subset which we can use bitwise-OR every element of those subset. So this means that there is a maximal value for those kind of subset, which when we all the kind of subset. So it asks how many the counts of the subset which have the bitwise or equals the maximal value. We know for the bit or uh, bitwise or there are those kind of numbers if they have all each other, and the result should be greater equal to the individual number. So we know the maximal max or result should should equal. I mean, for the subset which equals to the maximum or result, um, uh, as we are trying to get a max. If we all every numbers of these nums, that means it should be the maximal one, right? Because when we all a number, it should be greater equal to the original data. And the all of the numbers of these nums, that is superset of what we are looking for, right? So the things that we can firstly get the all number when we all every numbers from this kind of nums. After this one, we use the DFS combination, trying to see how many the result, how many subset, right? So that is the for we are trying to choose the subset from these nums, trying to see whether the result equals this all number. And if it is equals, right, then we add to the final result. So just use that is the DFS termination condition. So let's write code for this. So we know the target, right? That is the maximal result. Initially, let's set as 0. So what we do is for every num in nums that we have a target all and num. So we know the max all result is this target. So that is we are trying to get a DFS, right? Let's have a result new int 1 in the DFS. So we have nums and 0 target current or number in the result, right? So in the end, it's return result 0. Void DFS int nums. So we are trying to see how many subset has a all number to a target, right? So current index is index, and we have int target, and current all number in the result, right? And so what we do is that if current equals um equals target, right? Then we're going to have result 0 should increase here. The things that we should not terminate, right? We should not terminate because we want to see all of the subset. So we cannot add a return here. So what we do is that for int I equals index I smaller than nums, but less I plus plus. Then we're going to have DFS again, right? Nums I plus one target. And for this number is current all nums I in the result. So this will be the code. And doing like this, for every number, it has two options, select or not select. So the time complexity will be n 2 to the power n, right? But the things we can get things terminate early. For example, if we find a subset, for example, an index I and J and K, right? If we find this kind of subset, it's already equals to the target. Then every subset includes this IJK should, if we all the numbers should also equals the result, right? So that means if the length is n, right? That means for this kind of k to n, there are two options. That is to select or not select, right? So we have 2 to the power, actually that is n minus k, right? So that is n minus index choices, right? So we don't need to do DFS in a deeper layer. We can return, right? Instead, but for the result, we can add this kind of value, right? And for this value, right, we know in the last one is that is the index is going to n, right? So for this one, there is one choice. So that is um, one right shift 0, right? So for the other case, that is n minus index, right? So we can write we can get things simpler. That is should plus equal to 1 left shift nums dot length minus index, right? So, but here we don't need to do the deeper recursion, right? So we should return. Don't forget to return. If we don't have a return, it will be wrong, right? So you'll see this is much faster. And Python code will be very similar. We need a target equals 0. Then for num in nums, we'll have a target or equal to num, right? And we also set a result equals an reference, right? So DFS nums 0 target current result in the return result 0, right? So for the DFS, we can def DFS, and we have nums index and current result. And what we do is that if current equals target, then we'll have result 0 should plus equal to and this one, right? Shift go to power nums minus index. And don't forget to return. Then we'll say for I in range index to length nums, right? We're going to DFS nums I plus one and current all nums I and the result. Right? DFS nums index. We need to have target, right? Target. Okay. So the things that we can just if we don't want to get just a code simple, right? We can just have result plus plus. But forget don't write a return because we need to recurse over all the situation. But we can terminate early once we find it because if we find a subset here uh which all result to the maximal value, every subset, right, to the rest include these kind of three elements that have a choice select or not select that has 2 to the power n minus this index, right? Should all has all result to our target. Okay, so this is 2044.